Hello Math 1, this is our 7th lesson of remote learning, and we are continuing factoring with doing something called factor by grouping. But before I do that, I wanted to show you guys an example of the kind of exercises that I asked you to do on the last assignment, the whole idea of what is polynomial, polynomial review number 2. So if I said to expand this, it's basically like do some polynomial multiplication. We've got a binomial times a binomial. You get rid of parentheses. I think you guys are pretty strong in this idea that you're going to take the first times the first, which is 2 times 4, 8. A times C, you just say it's AC. Then you're going to take 2A times 5D. Okay, that would be plus 10AD. Then you're going to take the second times everything in the second group. 3b times 4c would be 12bc. And then 3b times 5d is plus 15bd. Okay, now this seems pretty random right now, but trust me, it'll come into play. If you try to combine like terms, you'll notice that AC can only be added to or subtracted from another AC term. Well, that's AD. That's not the same thing. BC, also not the same thing. BD, totally different. So this cannot be grouped with anything to make it to simplify it. But the same thing goes for all of these. So the idea is factoring. If you go back to last week when we talked about taking the GCF out, it's like doing the opposite of the distributive property. We're undoing distribution. There should be a way to go from this expanded polynomial and undo that to move back to this fully factored version. Okay? That's what I'm going to show you guys how to do today. Is how do we take something that really, if you look at it, none of these terms shares anything but 1. Like we could do the breakdown of 8, 10, 12, and 15. They only share 1. AC, AD, BC, BD, they don't share anything. But if you were to group the terms together like this and group these two together like this, I think you're going to notice, hey, I see an A. You could take an A out of that. And these are both even, so you could take a 2 out. You know, these both have a B that you could take out. And these both share a 3. So let's get to it. So instead of thinking, what does everybody share, specifically if there's 4 terms in a polynomial, instead of thinking, what does everyone share, why don't we think, what do these 2 terms potentially share? So I'll write that a little bit bigger so you can see it. Versus these 2 over here. So if you want to, you can think about this in terms of the greatest common factor using prime factorization. So 15y, if we broke that down, it's just 3 times 5. So that would be 1 times 3 times 5 times y. Okay, and then negative 35 would be a negative 1 times a 1. 35 is 7 times 5, so it's just going to be 5 times 7 and nothing more. They share a 5. They also share a 1, but from here on out, I'm not going to circle the 1s unless that's the only thing they share. Okay, so I'm going to kind of leave the 1s alone for now. The GCF for just this group is going to be 5. Okay, the leftovers, remember, the leftovers are, in this case, 2 different terms. So this is 1 times 3 times y, 3y, but then I have to separate it with a plus or a minus because they're 2 separate terms. Don't just lump it all together. It's going to be minus 1 times 1 times 7, that's minus 7. Okay, so I've successfully factored the first group. Let's check out the second one. So 9xy is just 3 times 3. Got to put the x at the end because there's a variable. Negative 21x is negative 1 times 1. 21's 3 times 7. and then make sure that, oh, I forgot a y here. Okay. Make sure you put the x on the tail end of that. You'll notice they share a 3. They share an x. And again, I'm withholding this idea of circling the 1 so that only when it counts we'll actually have to circle it. So then the GCF over here is a positive 3x. Okay, that's what they share. They share a 3. They share an x, 3x. The leftovers, it's going to be 1 times 3 times y, which is 3y. Okay? And then this is negative 1 times 7, negative 7. Okay, so hopefully you guys notice something's interesting between these two. They both have the twin 3y minus 7. So if by factoring both parts of the group, this looks very, very, very similar to when we split apart polynomial multiplication. It's almost as if we originally had 5 plus 3x. So this is just kind of like an aside type deal. All right, so we're just thinking about this over here. If we had 5 plus 3x times 3y minus 7, remember, the way by which I told you guys you should expand these or multiply the polynomials back in the day, all right, last chapter, which is really last lesson now, is you say take the 5 and multiply that by 3y minus 7. Take the 3x, take that times 3y minus 7. All right, so I'm hoping you guys are making a little connection here where if factoring is the reverse of the distributive property, okay, factoring is the reverse of the distributive property, I am just going from this step backward to that. And once I have the two blocks multiplied together, that means I've successfully factored it. So that's my answer. So if I see this, I'm thinking, oh, go one step backward and say that these two were together in one polynomial. It was 5 plus 3x. And now they're grouped together. And then the 3y minus 7 that occurred in double, that's only what happens when you're trying to multiply these. And then it goes backward to just 1 3y minus 7. Okay. You could also think about this as you now have two blocks of multiplication happening here, and they've got a greatest common factor now of 3y minus 7. So you could technically take the 3y minus 7 out and make that your GCF, and then you multiply that by the leftovers, which would be 5 and 3x. I found that explanation actually isn't as helpful for freshmen, so I've kind of abandoned that and just talked about how, hey, do you guys see the pattern? It's going backwards. Let's do some more examples. All right, so I'm going to rewrite this so that you guys can see it better. Now, the first thing I think you guys are wanting to do is, hey, I've got two x terms in the middle that I normally would combine and simplify it that way. Well, remember, we're not simplifying the polynomial. We're reversing the process of distribution. We're not simplifying it. We're trying to create two blocks multiplied side by side. So we need to think to ourselves, I'm not trying to simplify the middles here. I'm trying to say these two and these two need to be individually factored, and then maybe we can do that reverse move at the end like we did on the previous example. So let's take a look at 3x squared minus 2x. If we did the prime factorization, you get 3x squared is just 1 times 3 times x times x. Negative 2x is negative 1 times 2 times x. All they share is an x. So I'm going to put the x on the outside here. And then on the inside, it's going to be 3x minus 1 times 1 times 2 is 2. So 3x minus 2. On this second part here, 12x minus 8. 12x is equal to, let's see, that's 2 times 6, and 6 is 2 times 3. So it's 2 2's and a 3. Make sure you don't forget the x. Negative 8 is negative 1 times 2 times 4. 4 is 2 times 2. 1, 2, 3 2's. Check out what they share. They share a pair of 2's, and they share 2 pairs of 2's. So then that means your GCF is going to be a positive, because I didn't circle a negative 1, 2 times 2, which is 4, so a positive 4 times, and here's the deal. You should be getting twins in your leftovers. If you're not, then something went terribly wrong. Do we have 3x? We do. 1 times 3 times x is 3x. Do we have a negative 2? Negative 1 times 2 is minus 2. Okay, so we've got our GCF x and our GCF plus 4. Maybe think about it in terms of my GCFs create their one term together. So this is going to move backward in the process of distribution, and I'm going to have now x plus 4. I'm taking the GCF from my first and the GCF from my second. They work backwards and become a new polynomial themselves. And then we multiply that by the 3x minus 2. And just to convince you guys that this actually successfully factored it, take the existing polynomial and just ask yourself, if I were to multiply that out, if I were to expand it, would I get 3x squared minus 2x plus 12x minus 8? Well, to expand it, you take the x there, multiply it by 3x minus 2. You take the plus 4, multiply that by 3x minus 2. X times 3x is 3x squared. X times negative 2, here I'll draw the arrow so you guys can see it more clearly. X times negative 2 is negative 2x. 4 times 3x is plus 12x. 4 times negative 2 is minus 8. It matches, which means we've successfully factored it. I'd encourage you guys to do the reverse of that, to check it every single time, just to kind of convince yourself that you did it right. I'm going to stop the video and then start a new one so that I can get through all the examples on this notes.